Number system conversions, we'll start with binary to decimal. So here's an example. What you do is remind yourself of what the places represent. And then add up all of the places that are ones. So I have one group of 64s, one group of 16s, one group of 8s, one group of 2s, and one group of 1. So I add them up, 11, 21, 80, 90. So that is 91 in binary. Next, the other way around, decimal to binary. And we'll do 275. So what you need to do here is remind yourself of what the places are that you can work with binary. Ones. Again, going up by 2 times each place. So at this point we can pause. We're going to need more than a place of 32s to get to 275. In fact, we're going to need to go beyond 128 to 256. So with 256, we can represent 256 of this 275. So what's the difference? So we'll put a 1 here. We'll use that for sure. And then 275 minus 256 is 19. So we need 19 more to get to 275. We won't need that. Can't need that. Can't need that. But there we go. 16. So 19. You can still see this here. Minus 16 gives 3. So we'll take our 16 place. We need 3 more, which we can get right here. So that's a pretty good example. Fill the zeros in. A group of 256, and a group of 16, and a group of 2, and a group of 1 equals a total of 275 decimal. So this is 275 decimal represented in binary. So there is your decimal to binary and binary to decimal. Next, we'll do hex to binary, or binary to hex. You do the same thing for both of these. And what you do is you write down all of the equivalent binary 4 bits for the single bit hex. So hex will be over here. You can see it, yes. And binary equivalent is here. And the shortcut way, the foolproof way to do this is as I'm going to do it. I mean, you can go through and just write them one at a time, 0, 0, 0, 1 for 1. And you know, you've used all of your places there, so 0, 0, 1, 0, 0, 0, 1, 1. Now you've used all of your, if you include 0, you've used all of the combinations here, blah, 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 blah. Or, like I say, the shortcut way is to do the following. 8 zeros by 8 ones. Okay. And then the next column is going to be groups of 4, 4 zeros, 4 ones, 4 zeros, 4 ones. And then pairs, 2 zeros, 2 ones, 2 zeros, 2 ones. And then alternating 0, 1, 0, 1, 0, 1, 0, 1. Matched up to do this, but I will for this video. Matched up to 9. 10 is A. And so, if I were to give you a binary number and ask you its hexadecimal equivalent, it's easy. Just group the binary number into groups of 4, working from the right to the left, and look it up on the chart. So for example, and they don't necessarily have to be given to you in groups of 4, so I'll put them like this. I'll work from the right, group them in groups of 4. That one, 1, 0, 1, 1, is B. And this one, 1, 0, 1, 0, right, is A. It's a little bit tricky if they don't give you a multiple of 4 in the example. So for example, that one. You don't read from left to right, you read from right to left. Group 4, 1, 0, 1, 0. Go back to A again. This one is going to be 0, 0, 1, 1, which is 3. So I put in the leading zeros. Working the other way around, let's do 2, B, 9. You have to remember that hex is base 16, 16 to the power of 0 with the 1s, 16 to the power of 2, 16 to the power of 1, 16 to the power of 2. So the 1s, 16s, and the 256s. 2B9 is 2 times a group of 256s, which is 512. B, groups of 16s. And B is where it's a little bit tricky. What's B? B is, well, I should have done this too. So that's like 10, 11, 15. So the B times a group of 16s is 11. 11 times 16, 160, 176. And 9 ones. So 15, 17, 7, 9, 697 is the decimal equivalent of this. Oh, right. So I jumped ahead of myself there, sorry about that. That's hexadecimal to decimal. Hexadecimal to binary, the last one that we need to do then, is easy. You just read off the chart. So I'll do the 2 up here. 2 is B is, and 9 is, right, so I ended up doing a lot there all at once, but this is going one step from hexadecimal to binary, and also going one step from hexadecimal to decimal. The end.